Assalamualaikum to Dr. Arif and my fellow friends. So today we are from Group F will present image encryption based on the general approach for multiple chaotic system written by Kais H, Al-Safasfe, Auda A and R4. So allow me to introduce our team members. First one is Muhammad KHALID bin LALIM, JUSMAN JUSPIN, Muhammad LUQMAN HAKIM bin MAHADI, Nurul Asyiqin binti BAHARI, MALIYANAH binti JAFRY, and SITI YUSLIZAH binti Muhammad YUSUF. Okay, I will start with the introduction. Non-linear dynamical systems have increasingly used chaos in recent research. Image encryption schemes are being studied to meet the demand for secure image transmission over networks. Traditional encryption algorithms like the data encryption standard are not suitable for image encryption. So, chaos-based encryption has suggested a new and efficient way of fast and highly secure image encryption. Chaotic systems have important properties related to cryptographic requirements. Since 1989, increasing research has been based on chaotic systems for image encryption technology. However, this method have drawbacks like small key space and weak security. So this paper proposed an image encryption scheme combining two chaotic systems, which are Lorentz chaotic system and Rosler chaotic system, and then compares the result with other techniques. So these are the two chaotic systems. The first one is Lorentz chaotic system. The system is a system of three ordinary differential equations that known as the Lorentz equation. So the equation is the first one, dx over dt equals to sigma y minus x. dy over dt equals to rx minus y minus xz. And dz over dt equals to xy minus bz, beta z. For this example, the arbitrary parameters used are sigma equals to 10, r equals to 28, and b equals to 8 over 3. And then the MATLAB's 45 range quota routine was used to solve the differential equations. We move to the Rosler chaotic system. This system consists of three differential equations that have a simpler strange attractor than Lorentz. We can say that it's a system of three non-linear ordinary differential equations. It has only one quadratic non-linear exact numerical integration that will show the system has strange attractor. So the equation is dx over dt equals to negative y minus z, dy over dt equals to x plus ay, and dz over dt equals to b plus z times x minus c.
Hi, I am MALIYANAH binti JAFRY and my metric number is BS2110359. We'll continue from here. In the recent years, researchers developed image encryption methods based on chaotic systems. The objectives of this paper is to propose new image encryption technique based on new chaotic systems by adding two chaotic systems, which is the Lorentz chaotic system and the Rosler chaotic system. The main advantage of this technique is stronger security, as is shown in the encryption test. That's all from me. I will pass to the next presenter.
Okay, so we move to the next topic, which is the explanation and demonstration of the proposed technique, which is the proposed scheme in this journal. So the first is the researchers or the most of researchers use chaotic image encryption and one chaotic system, which is Lorentz and Rosler system. This system is depending on the one chaotic system like Lorentz and Rosler system, and the chaotic was represent and is and it is based on adding two chaotic system, which is the Lorentz and Rosler. So the new chaotic system generated as shown as in equation of the number 2 of my point. So next is the um, most of researchers is agree on the following statement, which is chaos is a predict long-term behavior in a deterministic system that exhibit dependence on initial condition. So to examine, so next is the security level of the system increase from 3 to 6 parameters, which is the security of Lorentz and Rosler encryption method depends on three parameters. But in the proposed scheme in this paper, the security level was increased to 6 parameters. We move to the encryption-based multiple choice, which is in this system we need to step by step, which is to encrypt image by shuffling the pixel values, and then we changing the grayscale values to create an encrypted image. Okay, so the number two is after a set number of iteration, generated elements have been stored within the chaotic metric of size the same as the original image size. But this is depends on the size of the image. So we go to the flowchart. We go to the step by step of this multiple chaotic encryption system. So the first step is we need to set the key, which is initial condition and parameters. The parameters is must be in the acceptable interval. Step number 2. Generate the first mask with the same size of image. And we go to the diamond flowchart, which is perform the XOR between the chaotic mask and original image. So if the image is not encrypted, is not generate the second mask with the same size of image and perform the XOR between the chaotic mask and image from the XOR that from the XOR original image. And this is continue until we can encrypt the image and we pass the encrypted image to the system. And the encrypted image is passed to the encryption key and the system is fully the system is berjalan.
Hello, my name is JUSMAN JUSPIN, non-metric BS211100183, and I will present a few examples of image encryption based on the general approach for multiple chaotic system. So for the first one is Chen et al. Encryption algorithm. So this algorithm uses three chaotic systems to generate three sets of chaotic sequence, which are used to permute and diffuse the pixels of an image. The three chaotic system are chain system, Lorentz system, and a new 3D chaotic system. The algorithms provides good security and high encryption speed. Next, Zhang et al. Image encryption algorithm. So this algorithm use four chaotic system to generate a chaotic sequence, which is used to scramble the image pixels. So the four chaotic system used are Henon, Rosler, Chen, and Logistic. The algorithm provides high security good efficiency and robustness against attacks. The third one is Yang et al. Chaos-based image encryption algorithm. So this algorithm used for a chaotic system, including logistic map, sign map, chess system, and Lorentz system, to generate multiple chaotic sequence. These sequences are then used to perform confusion and diffusion operation on the image. The algorithm offers good security, low complexity, and high efficiency. So the last one is Hugh et al. Image encryption algorithm. So this algorithm uses 3 chaotic systems, including logistic map, 10 map, and Lorentz system, to generate 3 chaotic sequence. So these sequence are used to scramble the image pixels in both spatial and frequency domains. The algorithms provide high security and good efficiency.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAKIM bin MAHADI. So for the result, we can see that for the picture 1, when we encrypt the picture that we get is like a blurry effect, like a pixelated image. So and give like a meaningless image. So we can say that the encryption image is 100% obscure. And when we decrypt the encrypted image, it gives us the same original image, and where you can see that it has no single error from the decryption of the image, and the decryption image also is the same as the original image, and the image is clear and correct, and not blurry when we decrypt it. The histogram and PCR result, we can see that statistical analysis has been performed on the proposed image encryption algorithm. Encrypted image for LANA image is fairly uniform and is significantly different from that of the original image. So we can see that the first graph is for the original, and below it is the encrypted image. So we can see that the histogram for the encrypted image is fairly uniform. So the meanings of the uniform, we can see that the image is meaningless, and the pixel of the image also is fairly uniform. All of the pixel is fairly the same. And for the MPCR, we can see that the small chance of the plain text give significant value to the encryption scene. So for the example, so we can see that the first table for the horizontal, the plain text is given the value 0.9681, and the encrypted image is 0.0483. But for the second table, when we change small amount of the plain text for the horizontal, which is the value is 0.9804, the encrypted image change a lot, which give us the value 0.0219. It's a lot of the change from the table 1 and the table 2.
Assalamualaikum warahmatullahi wabarakatuh. My name is SITI YUSUF, and my metric number is BS211102997. So the conclusion for this article of image encryption based on the general approach for multiple chaotic system is, the first thing is there has been a new proposal for an image encryption strategy that make use of two chaotic system, which is the Rossler chaotic system and Lorentz chaotic system. And for the second point is, this picture encryption technique has a large key space, high levels of security, high level of obscurity, and high speeds. I think that's all from me. Thank you.